Charming boys and beautiful girls. Welcome to 100 Learning. I'm Janashruti. I'm here to teach you the formula sheet of this chapter circle. Yeah, in this chapter what we are going to see the important terms and formulas used and in this chapter to make this chapter and easy to go with a flow and make you an expert in this chapter. Let's go on to the video. First we are going to see what is tangent. What is tangent of a circle and the terms and formulas regarding this tangent. Before that, what the essential need we have to see is the term circle. What is a circle? Circle is a 2D shape. What is it? It is a 2D shape. It can be formed by the following steps. We considered a fixed point called center of a circle. From this point, we plot all the points which are equal distance from the center. I'm going to plot all the points which are equal distance from the center. That distance is denoted as radius of a circle. What is it? It is a radius of a circle. And we join all these points to make a circle. In this way, the circle is formed. So we can able to understand what is center and radius and how a circle is formed. These outer area coverage is also known as circumference of a circle. This boundary, otherwise we stated as boundary. This boundary is stand as circumference of a circle. Let's move on to the chord term. What is chord? Chord is a line. It's just a line segment. What it looks like a chord. When we call a line as a chord, when these lines are joined by any 2 points on the circle. If I have a circle and I join by 2 points, a line is joined by 2 points on the circle. This line becomes chord. Can you all understand? When a line become a chord, when this line have a points on the circle. And the term we call secant. Secant means it's a line segment. It's a line. It's called a line which cuts the circle exactly at 2 points. Which cuts the circle. It's called secant. Secant means cut in Latin. So what is secant? It means cut. It's going to cut the circles at 2 points using these 2 points. Okay. And what we call a tangent. Tangent is also a line. A chord, secant and tangent. This all represent a line. It differs by the terms we used. A tangent means it's never cut a circle. It touches the circle. It gives a plenty and gentle touch to the circle. Exactly at 1 point. Then a line becomes a tangent when it touches the circle without cutting it and exactly at 1 point. And what about arc? I generally term what is circumference. Circumference means it is the boundary of a circle, right? So in this boundary, if any part of that boundary is called as arc. For example, this is the boundary of a circle and any part of this boundary, how much longer it can be. It can be how much long. Whether it is a maximum part or it is smaller part. We named it as arc. What do we name? It is arc. And what is segment? Segment comes when a chord plays a role. If a circle is connected by a chord, this chord literally divides the circle in 2 parts. You can see like in this way. Where this smaller part is known as minor segment and this larger part is named as major segment. What is it named? Major segment. Yeah, segment comes when a chord plays it. And what is sector? Sector comes when arc plays a role. Yeah, we are literally having a circle and we are having an arc which has been cutted from a circle. This arc is cutted from the circle. This part is called sector. Same. This sector is known as minor sector and this sector is known as major sector. Literally, we can imagine sector as a cake piece. When whole cake is there, we literally have a part of a cake. What is it? It is a piece of cake. For remembering, you can have it. It is a piece of cake. When we say sector, it is a piece of cake which has been cutted from a whole cake. In that piece of cake is minor sector and that whole remaining leftover cake is called major sector. We are going to move on to the next concepts. What is given? That equal cards of a circle. Okay, let me have a circle first. Let me have a circle. Then there are cards. I am having two cards. When I am going to say these two cards are equal, when it makes equal angle to the center. This angle and this angle are literally equal. Then we can say these two cards are equal. And what about the second point? In the same field, I am going to have a circle. In that, from the center to the card, one perpendicular is drawn. From the center, a line is drawn to any card of the circle which makes it bisect. Bisect means what? The word bisect means the line will be divided into two equal parts. Then we say it is bisects. Actually, when a line from a center, from a perpendicular line from a center drawn to a circle, then it definitely divides the card into equal two parts. And in a circle, when two cards are equidistant, I am saying these two cards from the center distance are equal, then this cards will be equal. When the distance from the cards are equal, then the cards are equal. What is congruent arc? Congruent arc means it is a same size arc, suspend same equal angles. If I am saying in a circle, same size. Congruent arc means same length arc. If I am having two arcs which are of same length, which makes angle to the center, then these angles must be equal because of this equal length arc. And the next point is what? I am having an arc. Let me consider one circle and an arc. It makes angle at the center at any point on the circle. It may be here, it may be here, it may be here. It varies. Okay. Let me have this one. This angle is theta. Fine. And let me have this arc makes an angle at any point of the circle at alpha. Fine. Then we can relate these two angles by this one. This theta is equal to 2 times of this alpha. So what it indicates? The arc makes an angle at any point of the circle will be half of the angle made at the center. This means the center angle will be double of any angles which was made at any of the point on the circle. Fine. Next we move on to the angles in the same segment of a circle. Fine. When we hear the word segment, we have to draw a card. We are having a circle and I am having a card. Fine. This segment is called major and this segment is called minor. They are saying what? The angles in the same segment. Right? So in the same segment, I am going to draw 2 or more angles. then these angle, this alpha, beta must be equal because these two angles lies in the same segment called major segment. Fine. Then what is saying? An angle in the semicircle is a right angle. Whatever. If I have a semicircle, this is called semicircle, which is a half of a circle. Then I am making angles at semicircle. At whatever point you draw, it definitely makes right angle. What angles it makes? It definitely makes right angle. And the sum of either pair of opposite angles of a cyclic quadrilateral. What is cyclic quadrilateral? First I have to draw a circle and a quadrilateral. Quadrilateral means it is a shape which has 4 vertices or 4 corners. Okay. That 4 vertices are formed from the points on the circle. I am going to draw a quadrilateral like this one, which has the vertex on the circle. See, and these quadrilateral, the opposite angles A, B, C, D. A plus B will be equal to 180 and this C plus D will be equal to 180. Fine. Let's move on to the next one. Okay. Now we know what is tangent and how it is formed. Okay. Then we can think about the next advanced level. How many number of tangents can be drawn to a circle? We're going to find this one by using these terms. First of all, what is the length of a tangent? Remember what I said? What is the definition of a tangent? I have to draw a circle, and tangent mean is a line which gently touches the circle, right? Yeah, it gently touches the circle. I have to find the length of these tangent. How we can find it? Take the center. Fine. This center makes the perpendicular to the tangent, right? And I'm going to draw a line which intersects the tangent at a point called P. And from center I'm drawing a perpendicular line called B. This measurement, the distance of PB is equal to length. We call the length as PB. You got it? How we can have the length of a tangent. Then we move on to the concepts regarding number of tangents from a point. Okay. It varies as the point lies positions. Okay. First we are going to see the case by case positions. When a point lies inside a circle, I'm going to have a circle. When a point lies inside a circle, we know that a tangent means it gently touches the points on the circle. When it lies inside the circle, there is no tangent passing through this point. So it is no. There is no tangent passing through the point when the point lies inside the circle. Then we can move on to the next case when the point lies on the circle. Exactly, we have when a point lies on the circle, this point. How many tangents can pass through this point? Only one. Exactly. Only one passes through this point. When a point lies on the circle, one tangent can be possible. Okay, let me discuss. When the point lies outside the circle, out of the world, okay? I'm having a point called P outside the circle, and from this point, I am able to draw two tangents. I am able to draw two tangents from a point outside the circle. You got it? When a point lies inside, no tangent will pass through the point, and when it is on the line, there will be possibility of one tangent, and when it is outside the circle, there is possibility of two tangents. Okay, what we will do with these tangents? Let me get in the point. when two tangents are drawn to a circle. Okay. So for this case, we are going to study the concepts. The angle suspended by the angles. When I have this point, see, this makes angles. This is center. This center, from the center to that point, makes two angles which are equal. What is it? Which are equal at the center, and it is also equal at that point. Which point? P point. Alpha, beta. That alpha, beta will be equal. So, when a tangent drawn from an external point, there are two possibilities. The angles make that the center will be equal, and the angles makes that the external point will be equal. When two chords of the circle intersect, see, I have to draw a circle and I have to make two chords, right? I have to make these two chords to intersect. So I extend these lines. It intersect. Okay. Then the product of the length of their segments are equal. What it mean? What does this line indicates? We are going to draw circle in two forms. It's saying that two chords will intersect. It haven't mentioned that it is internal or external. So we are going to make it both for internal and other side for external. When I am making two chords or intersect at internally inside the circle, and I am making other two chords which are going to intersect outside the circle. Fine. They are saying what? The product of the length of their segments. This segments means their line segments. This chord is called AB and CD intersect at point P. Then this segments AP into PB. AP into PB will be equal to this chord segment called CP into PD. In the same process, it will be repeated here. AP into PB is equal to CP into PD. Hence, it is proved. Then, what is it? If PAP be a secant. I already mentioned that what is secant. Secant means it is a line which are used to cut circle at 2 points. So, we are making a circle and drawing a line which cuts circle at 2 points called AB. Fine. This circle, and I'm making a point called P from an external point. Okay. To a circle which intersects at the point A and B, and I'm making the tangent for PT which passes through the point P and makes a tangent to this circle. Fine. At a point called T. This tangent makes a point T to the circle. Then we can say that this PA into PB will be equal to this tangent line PT square. Okay. Fine. Next we move on to the next point. If two tangents are parallel, okay, we are making a circle and we are drawing two tangents. I have to make these two tangents parallel. So I am making one as upside and others which looks like parallel, right? At a point A and it's at B. Then this tangent will be connected by a line which is diameter of a circle. If a line is drawn between these two parallel lines, okay, if a line segment joining their point of contact, it must be diameter which joins the point of contact if the tangents two are parallel to each other. Fine. We came to the last section of this video which is called alternate segment theorem. What it mean? If a line touches the circle at a point, fine, and if a card is drawn from the point, okay, it means we are going to draw a tangent at a point called T, and from this T I am going to make tangents. Card, sorry, I am making a card. This card makes angles at different segments, okay. Then the angles formed between the card and the tangent. This card and the tangent. Neither this one or this angle. These two are the angles which are formed between the card and the tangent, which are equal to the angles in the alternate segment. This angle will be equal. This angle will be equal when I make angles in different segment. This angle lies in the major segment, then this major segment angle will be equal to the angle made by the card in minor segment, and this theta which is formed in the minor segment will be equal to the angle made by this card in the major segment. Fine. Okay, we came to the end of this video. Now I'm going to end this video. Please be careful while using all the terms and properties used in this video, and listen 2 or more times to make it familiar, and do best in your exam. Thank you for this video. All the best for your exam.